In the previous video, you looked at convolutions and got a glimpse for how they worked. By passing filters over an image to reduce the amount of information, they then allowed the neural network to effectively extract features that can distinguish one class of image from another. You also saw how pooling compresses the information to make it more manageable. This is a really nice way to improve our image recognition performance. Let's now look at it in action using a notebook. Here's the same neural network that you used before for loading the set of images of clothing and then classifying them. By the end of Epoch 5, you can see the loss is around 0.29, meaning your accuracy is pretty good on the training data. It took just a few seconds to train, so that's not bad. With the test data as before and as expected, the loss is a little higher, and thus the accuracy is a little lower. So now you can see the code that adds convolutions and pooling. We're going to do two convolutional layers, each with 64 convolutions, and each followed by a max pooling layer. You can see that we defined our convolutions to be 3 by 3 and our pools to be 2 by 2. Let's train. The first thing you'll notice is that the training is much slower. For every image, 64 convolutions are being tried, and then the image is compressed, and then another 64 convolutions, and then it's compressed again, and then it's passed through the DNN, and that's for 60,000 images that this is happening on each epoch. So it might take a few minutes instead of a few seconds. Now that it's done, you can see that the loss has improved a little. In this case, it's brought our accuracy up a bit for both our test data and with our training data. That's pretty cool, right? Now let's take a look at the code at the bottom of the notebook. Now this is a really fun visualization of the journey of an image through the convolutions. First, I'll print out the first 100 test labels. The number 9, as we saw earlier, is a shoe or a boot. I've picked out a few instances of this, where the 0th, the 23rd, and the 28th labels are all 9, so let's take a look at their journey. The Keras API gives us each convolution, and each pooling, and each dense, etc. as a layer. So with the Layers API, I can take a look at each layer's output, so I'll create a list of each layer's output. I can then treat each item in the layer as an individual activation model if I want to see the result of just that layer. And now, by looping through the layers, I can display the journey of the image through the first convolution, and then the first pooling, and then the second convolution, and then the second pooling. Note how the size of the image is changing by looking at the axes. If I set the convolution number to 1, we can see that it almost immediately detects the laces area as a common feature between the shoes. So for example, if I change the third image to be 1, which looks like a handbag, you'll see that it also has a bright line near the bottom that could look like the sole of the shoes, but by the time it gets through the convolutions, that's lost. And that area for the laces doesn't even show up at all, so this convolution definitely helps me separate a shoe from a handbag. And again, if I set it to 2, it appears to be trousers, but the feature that detected something that the shoes had in common fails again. Also, if I change my third image back to that for shoe, but I try a different convolution number, you'll see that for convolution 2, it didn't really find any common features. To see commonality in a different image, try images 2, 3, and 5. These all appear to be trousers. Convolutions 2 and 4 seem to detect this vertical feature as something they all have in common. If I again go to the list and find 3 labels that are the same, in this case 6, I can see what they signify. When I run it, I can see that they appear to be shirts. Convolution 4 doesn't do a whole lot, so let's try 5. And we can kind of see that the collar appears to light up in this case. Let's try convolution 1. I don't know about you, but I could play with this all day. Now see what you do when you run it for yourself. When you're done playing, try tweaking the code with these suggestions. Editing the convolutions, removing the final convolution, and adding more, etc., etc. Also, in a previous exercise, you added a callback that finished training once the loss hit a certain amount, so try to add that here. When you're done, we'll move to the next stage, and that's dealing with images that are larger and more complex than these ones, to see how convolutions can maybe detect features when they aren't always in the same place, like they would be in these tightly controlled 28 by 28 images.